And what a better way to bring in the new year, but with exponents, okay? So that's what we're going to be doing today. So we are talking about exponents and exponential functions in this unit. Exponents are going to be very important as you move forward through Algebra 1 and into geometry, even non-Regents geometry, regular geometry, and definitely in Algebra 2. So these next few lessons, especially today, are going to be important for us, okay? So today what we're going to be talking about is the product rule, the quotient rule, power rule 1, and power rule 2, okay? So these are going to be all in today's lesson. So EF-1, okay? So this is what we're going to be talking about today. I'm going to hold off on the examples. This is just a reference sheet for you, and we're going to do a bunch of examples, okay? So some vocabulary, a monomial. So when we're looking at exponents, we're looking at monomials, okay? We're mano y mano, man to man, one to one, okay? So a monomial is just one term in your full expression or equation, okay? What it looks like is this, okay? So you have something raised to an exponent. So that something is always called your base. You could have a to the 10th. You could have b to the 5th. You could have 10 to the 4th. This right here, these are all of your bases. So whatever you're raising is your base. The thing you are raising it to is called the exponent, okay? So that just tells you how many times your base is actually there. So this 5 squared is the same thing as writing 5 times 5, okay? So it would be 5 written twice because the exponent is 2, all right? So now that we got vocabulary down, that's literally all the vocabulary you need to know to do this. So the first thing we're going to talk about is the product of powers. So if multiplying two numbers with the same base, you add their exponents. So multiplying with the same base, you add the exponents. Now, we're going to actually prove that to ourselves right here. So if I can zoom in, make it a little bit clearer. This says 5 squared times 5 to the 6th. Okay, well, if I rewrite this, 5 squared is the same thing as writing 5 2 times, okay? So this would be 5 times 5. Now, I'm going to multiply it by 5 written 6 times. So I have 1, 2, 3, 4, 5, 6. Okay, now I'm going to put this into my calculator. The first term is 5 times 5, okay? Well, that is, you can't really see it that well, but it is 25, okay? So this is 25. And then I'm going to put it in here 6 times. So 5, 2, 3, 4, 5, 6. So 5 times 5 times 5, blah, 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 blah. 6 times gives me 15,625. So 15,625. If I multiply these two things together, so 15,625 times 25, that's going to give me 390,625. So 390,620, and 25. Okay. Oh my gosh, there must be an easier way. An easier way is if multiplying two numbers with the same base, that means that this number that everything is being raised to is the same, you can add the exponents together. So what does that look like? Well, the base, rewrite the base is 5. They're both 5 raised to something. And then you can add the exponents. So I will have 2 plus 6. Okay. So now let's simplify this. So I would have 5. 6 plus 2 is 8. Okay, which, hold on a second, let's look here. I have 1, 2, 3, 4, 5, 6, 7, 8. That's 8 5s, okay? So 5 raised. So if you ever want to raise anything, you hit this little caret underneath the clear. So raise to the 8th is 390, 625. 390, 625. Okay, right? Because this is basically a shortcut, so you don't have to write everything out 100 million times, because there's going to be a lot of times where you're going to have something that's like y to the 50th or something like that, and you don't want to write 50 of those things. I didn't even want to write 6 of those things, okay? But it is equivalent. You have 8 5s here, and 6 plus 2 is 8. So if you have the same base, you just add the exponents, okay? So let's not write out that many y's here and count them. We're just going to add the exponents together. So the first thing you have is the same base of y. So y, y, y. Okay, y. Okay, you have 4 of them plus 3 more of them plus, now be careful, just because there's not one here written, there's a 1, okay? Because if there was a 0, it would be something special, and we're going to learn that later. Y to the first, so you would have 1. So this would be 4, 7, 8. So this would be y to the 8th. 4, 5, 6, 7 plus 1 is 8. Alrighty, so now we're just going to get a little bit more complicated and throw numbers into the mix, but don't worry, the numbers go with the numbers and the letters go with the letters, just like we would be solving. So I'm going to first have 7 times 6. I'm going to put the numbers with the numbers, and then I'm going to have y to the 5th times y. Because remember, parentheses means multiplication, okay? So 7 times 6, oh, I don't know, my golly, 7 times 6, 42. Okay, and when I'm multiplying my exponents, I'm going to add them together, okay? So I don't see anything here, so there must be a 1. So this is y to the 5th plus 1, okay? So what I'm left with is 42 y to the 6th. Because 5 plus 1 is 6. Okay? Alrighty. I'm going to do the same technique here because there's now x's and y's. I'm going to put numbers with numbers, x's with x's, y's with y's. So I'm going to get -3 times 5. So took care of that, took care of that. I'm going to put my x's together now. So I get x squared here and an x here. Okay, and then I get y to the 7th times y to the 6th. Okay, so now let's simplify this thing. So I'm going to get -15 here. When I'm multiplying, I'm adding my exponents. So I'm going to get x2 plus, oh my gosh, I don't see something. So there must be a 1 there, and there is. So 2 plus 1. And then this one gives me y to the 7 plus 6. Okay, well, that gives me -15 x. 2 plus 1 is 3. And y, 7 plus 6 is 13. And that's it, okay? So if you are multiplying things together, you are adding the exponents, okay? Remember, when you multiply a lot, things get bigger. But what happens when you divide? So if I cut something in half, it gets smaller. So if you're dividing numbers with the same base, you actually subtract their exponents. And why does that work? Well, we're going to do it long first, okay? So at the top, I would get 6 y's. So I get 1, 2, 3, 4, 5, 6. And at the bottom, I get 1. Okay? Well, since there's 6 of them at the top and 1 at the bottom, that means I can cross one of these bad boys out. Okay, so what am I left with? I'm left with 1, 2, 3, 4, 5. I'm left with 5 y's. and they're all at the top. So I don't have anything at the bottom, so I guess it would be 5y over 1. But you don't need to write that. I would just put 5y to the 5, okay? Not 5y. You have 5 y's, that's y to the 5th, okay? Over 1, because you got rid of that thing down there, and it doesn't turn into a 0, because if it did, it wouldn't exist. So there has to be a 1 underneath here. So if I'm dividing by two numbers with the same base, I subtract the exponents. So what does that look like? I would have 6 at the top minus, okay, well, there's nothing here. That means that there's definitely a 1 on it. So I would get y to the 5th. Same thing, because they cancel each other out, okay? This is going to come in more handy later in your mathematics career. I would say this right here, multiplying, is going to be huge for us in Algebra 1, so that's the one you really want to be comfortable with. I have the same base of 6. That means that I can subtract the exponents. So I would have 6, 13 minus 2, which is 6 to the 11th. Okay. This one right here, no different, okay? So all you're going to do is simplify the numbers and subtract the exponents. So the first thing I would do is 10 divided by 15. Well, that gives me gross decimals. I don't want decimals. We don't want decimals here on out forever, for always. We don't want mixed numbers. Keep it as a fraction, okay? So if I want to know what this is and as a fraction, I'm going to hit math and enter. So that's going to be 2/3, okay? So the number part gives me 2/3. All right, I would have a to the 7 minus 5. And then I would get b to the 9 minus 9. Okay, so 2/3. A, well, 7 minus 5 is 2, and 9 minus 9 is 0. This is something special, and we're going to talk about this tomorrow or the next day. I forget, okay? But that is something special. Anything to the 0 power is something special, okay? But if you are dividing, all you're doing is subtracting the exponents, okay? Okay, so what happens if you have, oopsies, you can't even see it. If you have a power to a power, okay? So I have a base raised to an exponent, but all of that is raised to another exponent, okay? So we call this power to a power. If you're raising power to a power, you're going to multiply the exponents. And why does that work? Well, we're going to do it here, okay? We're going to do it right over this way. It says x squared is going to be written 8 times, okay? So I'm going to have x squared, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I can do that. Now, what's happening here? I am multiplying exponents all together. When I multiply exponents, what do? Well, I don't know. When you multiply, let me see. When you multiply exponents, you add all of them together, okay? You add all of them together. So I'm going to add. So 2 plus 2 is 4. 4 plus 2 is 8. 8 plus 2 is 8, 9, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16. 16. So this is x to the 16th. Okay, because 2, 2, 2, 2, 2, you add all that together, you get x to the 16th. All those 2's. All righty. Well, this is saying if you're raising a power to a power, all you have to do is multiply. Well, what is 8 times 2? Isn't that 16? Ooh, perfect. So I would have x 2 times 8. Let's use that. just x to the 16th power. Okay, that's all you do. You multiply your exponents. So here I'm going to have y times negative, raised to the negative 3 times negative 4. Okay, so negative 3 times negative 4 is to the 12th. Wow. Okay, and then the last one is power of each. This is power 2 in our little lesson on the front page. Find the power of each factor in the parentheses, then multiply. So this is basically kind of like the distributive law. So I have 4x cubed yz. All of that is going to be raised to the third power. Now, what does that mean? It means that everything in here is going to be raised to the third power. Okay, now watch how I write this. This is going to be, the base is 4 raised to the third power. The base here is x cubed. I'm raising that to the third power. This y is being raised to the third power. Z is being raised to the third power. Okay, now remember from above, what happens when I raise something to the fourth or to any power? I multiply the exponents. Okay, so here I would get 4 to the third. Well, let's just rewrite that. So 4 to the third is 64. So this is 64. And then I'm doing the same thing as up here. Okay, so I would have 3 times 3, which is x to the 9th. Okay. I would get 1 times 3, which is 3. And then I would get 1 times 3, which is 3. Okay, so I'm raising each individual piece. This is the same thing. Everything is being raised to the second power. So the first one I would have is 7 raised to the second power. X is the base, it's being raised to the second power. Y squared is the base, it's being raised to the second power. Okay? So 7 squared is 49. Remember, I don't have anything here. That just means there's a 1. And I would have 2 times 1, which is 2. And then this y is 2 times 2, which is 4. Alrighty. Same thing. Choo-choo. So I'm raising everything to the third power. So I'm going to have 6 raised to the third power. The base here is x to the 6. I'm raising that to the third power. The next one is y to the 7th. I'm raising that to the third power. The last one is z. I'm raising that to the third power. Okay, so 6 cubed is 216. Now, this is the same thing as up above. So I'm raising a power to a power. I multiply them. So 6 times 3 is 18. Okay. Y is my base. Power to a power, I multiply the exponents. So 7 times 3 is 21. And z is my base. There's nothing here, but there's still a 1 there. Okay. And 1 times 3, power to a power, is 3. Okay. So those are our 4 rules we're going to learn today. Now what are we going to do? We're going to practice. Alrighty. So using exponent properties, simplify each of the expressions as much as possible. So this is going to be combo. Okay. So first thing I need to recognize, these two things have the same base. The base is x. They're being multiplied. When I have same base and they're being multiplied, I add the exponents. So this is the same thing as saying x to the 4 plus 7, which is 7, 8, 9, 10, 11, which is going to be x to the 11th power. Okay. Next, I have something in parentheses being raised. So I have a power being raised to a power. Power raised to a power is multiplication. Okay. So this is going to be x, 4 times 7, okay, which 4 times 7 is 28. So I would have x to the 28th. Alrighty. Cool, cool, cool. We just left room for you to expand it out if you'd like, but we don't have to do that anymore. Okay, so first thing I see x, x, x. They all have the same base of x. I see no exponent on this one, but that just means that there's going to be a 1 there because we already said that if there's a 0, it would do something different. So there's going to be a 1, and then these are all being multiplied. When I multiply same things with the same base, I add them. So this is going to be x to the 1 plus 2 plus 3. So 3, 4, 5, 6. So this is the same thing as saying x to the 6. Okay. This one. Oh, I have power raised to a power times a power raised to a power. So power raised to a power is multiplication, okay? So this first one is x to the 2 times 3. And the second one is x to the 5 times 4. Okay, so I'm going to get x to the 6 times, okay, x to the 20th. Oh my gosh, but what's happening here? I have x times x, so I have the same base, and then I have exponents, okay, so I have the same base, and I have the exponents, so just like letter A and letter C, I can add these together. So this is the same thing as saying x to the 6 plus 20, which is x to the 26. Okay, so E, x to the 3rd times x to the 5th plus x to the 4th. All right. Well, this thing right here, these two things are being multiplied with the same base. So that means I can add their exponents together. So this is going to be x to the 3rd, 3 plus 5, plus x to the 4th. Okay. Well, what is 3 plus 5? 5, 6, 7, 8. That's x to the 8th plus x to the 4th. Hold on a second. All this time, when I've been combining these at this stage, can I combine these when I'm adding? No, you cannot, okay? I made that a big deal, right? So x to the 8th is not the same thing as x to the 4th, okay? You can only combine like terms when you're adding, right? So numbers go with numbers, x squared goes with x squared because you would have 4x squareds, and then you add 2 more x squareds, and those are all of the same thing, okay? This is x to the 8th. X to the 8th and x to the 4th are not like terms. They are not the same thing, okay? Therefore, this is x to the 8th plus x to the 4th, okay? That means you have 8 x's, and then there's x to the 4th is something different, okay? You cannot put those things together. Alrighty. So that's it. That would be our answer. This one, let's just reorganize this a little bit so we can see the same thing. I want the same bases together. So I'm going to rewrite this as, I'm going to put the A's together. So I have A to the 4th, and then I'm being multiplied by A to the 5th. And then in another set of parentheses, I'm going to put my B's together. So I'm going to have B cubed and then B squared, okay? And now what do I have? I have my bases are the same, and I'm adding the exponents. So this is going to be A, 4 plus 5 in this term. And then same base, adding the exponents. So I have B to the 3 plus 2. Okay, so I would have A, 5 plus 4 is 9. B, 3 plus 2 is 5. Okay. Oh, this one's a little tricky. So, first thing I want you to notice, I have A squared times B squared times AB cubed. Okay, well, this is a power with multiple things inside of it. So that means this power gets to go on these things first. This is no different. You take care of your parentheses first all the time, okay? So I'm going to rewrite this as a squared b squared. And then I'm going to have a, and when I'm doing power to a power, this is going to be a raised to the third, and then the base b raised to the third, okay? Same thing as a squared b squared. Now, I don't see anything here, so that just means that there's a 1. So 3 times 1 is 3. B, nothing there, but there's a 1. And 3 times 1 is 3. Okay, I'm going to put the a's and the b's together just like we did here. So I'm going to have a squared a cubed, a squared a cubed, b squared b cubed, b squared b cubed, okay? And now I have my bases together. Same bases are together. I'm multiplying, so I'm adding the exponents. So I would have a2 plus 3, and then b2 plus 3, okay? So that gives me a to the 5th, b to the 5th. By the time we're done with this unit or even this lesson, I hope you feel confident enough to go from this to this, okay? I don't need to see all these steps in between. This is just us being thorough with you, okay? All right, last 2 examples of, oh geez, no, there's a few more, but let's not rewrite a whole bunch, okay? So I have 2 bases. I have r and r. They're being multiplied together. That just means I add the exponent. So I don't see anything here. So this is a 1. So I would have 4 plus 1 is 5. So I would have r to the 5th minus s and s. So these are different bases, so I can't combine them. But s and s are the same. They're being multiplied. So I add my exponents together. And 3 plus 2 is 5. Okay, so you can certainly rewrite this if you want. I am not going to rewrite this. What I want to do is recognize what's happening here, okay? So I have x's, I have y's, and I have z's. Okay, all of these are being multiplied together, okay? When you multiply exponents with the same base, you add the exponents. So the first thing I'm going to have here is x squared times x to the 5th, okay? And if I'm multiplying, I'm adding. So 5 would be 6, 7, okay? Y, I have 4 times y to the 4th times y to the 3rd. That means that they're being multiplied together. When they have the same base and they're being multiplied together, I add the exponents. So I have 4 plus 3 is 7. And then z. Okay, I have z to the 5th times z to the 1st power, okay? When I have same base, I multiply them together, I add the exponents. So I have z to the 6th, okay? So just real quickly, this would be x squared, x to the 5th, times y 4th, y to the 3rd, times z to the 5th, times z. Okay? Multiply, multiply, multiply. Same bases, you add the exponents. Okay? All right, these are our last few examples here. They're nice and short and sweet. This is division, okay? Just a reminder, this would be the same thing as doing this. So 3x to the 3rd means you're going to have x times x times x over x. Cancel one of these things out. What are you left with? X squared. Why is that? Because x cubed minus x, oops. When you are dividing, you're subtracting your exponents. Just like that. So 3 minus 1 is 2. That means you're left with x2, okay? All right, I'm going to take care of this number first. So 18 divided by negative 3 is negative 6. 3 minus 2 is 1. So you're going to have c to the 1, or negative 6c, because I'm not going to rewrite that 1. That's not common practice. Okay, so 9 divided by negative 3 is negative 3. I see a to the third, and I see a at the bottom. When I divide with the same base, I subtract. 3 minus 1 is 2, so I would have 8 squared. And then b, I would have 5 minus 2, which is 3. All right, and then last one, negative 48 divided by negative 8 is 6. Okay, I'm going to deal with the c's first. I'm dividing, so I'm subtracting. 2, just remember, there's nothing here, so there's a 1. So 2 minus 1 is 1. Now I'm going to deal with the d's. So I would have, oh my gosh, there's not a 1 on there either, so there's a 1. So 4 minus 1 is 3. So this is 6d cubed. 6cd cubed. Okay. Now on to Delta Math to practice. Have a good day.